Okay, so here's a problem we'll draw the shear moment diagram for. We'll start like we normally do, is we'll find our reactions. So I'll go ahead and come over here and I'll draw my positive shear at A, and I'll draw my positive bending moment at A. So I'm making sure that I'm putting on my positive sign conventions for shear and moment. Now when I go to solve this problem, it's going to be easier if I take this distributed load and convert it into a concentrated equivalent. So to do that, I find the area under the curve. What's the area under the curve?
4 times 48.
Yeah, it should be 48.
At 6.
It's a rectangle. You guys should know that. So that should be 48 kips. And from A, what's the distance to the centroid?
6 feet.
6 feet.
On curve. Right, that's why I see the point, so I can clear them out.
So now I should be ready to go find my reactions. So I'll come over here and I'll sum moments. Where's a good place to sum moments? So we'll sum moments at A. Starting at A, using right-hand rule for my sign convention, what kind of moment is this? Negative. What kind of moment does the 48 kip equivalent force create about A? Positive or negative? Negative. 48 kips times 6 feet. Then I have this 60 kips. Oh, I didn't give you a dimension. Let's make this 8 feet. Sorry about that. So I've got 60 kips creating negative moment about A with a moment arm of 20. And then I've got this moment sitting at the end. With this sign convention, is this positive or negative? Negative. So that's another 100 kip feet. So I should be able to solve for the moment. And whatever all this is. Whatever 48 times 6 is, plus 60 times 20, plus 100. Somebody break out their calculator or the appropriate app. 1588?
The appropriate app.
So that's kip feet. So what does that mean? What's the bending moment at A? Negative 1500. I can now sum forces in the y direction. I'll have my shear force acting up. I've got 48 kips acting down. I've got 60 kips acting down. So it looks like the shear at A is 108. Positive.
I'm going to put the sheet online so we can finish.
Sure. So let's go ahead and make our template for our shear moment diagram. So I'll have a line for the beginning of the beam and the end. There's a transition here between this continuous load and this one, so that's probably a good spot. And I think that might be enough for right now. So let's go ahead then and let's draw the shear diagram. So we'll start with indicating positive directions for X and for the shear, and that all of our units will be in kips. So what's the shear at A? 108, and it's positive. So we should start off at 108. Now remember, our basic relationships are that the change in shear is the area under the load curve between whatever limits you're interested in, and then the slope of that resulting curve is equal to the value of the load. So applying the first one, what is the area under the load curve over the first 12 feet? 48. And it's negative 48. So I should have 108 minus 48 should bring me to 60. The slope of that curve is given by the load, and the load is constant and negative. So here's a constant slope that's negative. It doesn't look very, it's obviously not to scale. And if you did try to draw the slope, you would see that it would be what? 4 to 1. Drops 4 for every 1 you go. The change in shear is the area under the load curve. What's the area under the load curve for the next 8 feet? There is none, 0. So that means my slope stays, or my value stays at 60. The slope of that curve is given by the load, and the load is 0, so we have a 0 slope. So that section is rectangular. So there's my shear diagram. It says that the shear at the end of the beam is positive 60. Is that correct? Well, what if you were to take a little piece of that beam and draw a little wedge where the applied load on the left edge was 60 kips and the internal shear positive was there? What are those two things equal to? Oh, you can't. I'm sorry. I went off the top. You'll find that it's positive and it's equal to 60. And that's exactly what we have here. So that matches. Sorry about that. Okay, let's do the moment diagram. So here's my positive x-axis for the moment diagram. And our units for moment will be kips and feet. What is the bending moment at A? So we're going to start off at negative 1,588. Now we know that the change in moment is the area under the shear diagram, and that the slope of the moment diagram is equal to the shear. So looking at this first section here, the area under the shear diagram should be the change in the moment. What is the area under this curve? This is a trapezoid.
Break it up.
So the way you find the area of a trapezoid, remember, is you take the height on both sides and you average it. So that should give you an average height of 84. And then that height times the base. So what's 84 times 12?
A big number.
Calculator people. And that's positive area. 84 times 12. 1,008. So if I add 1,008 to this, I get 580. The slope of the moment diagram is equal to the shear. What's the shear? Well, it starts off positive and gets smaller to another positive value. So I'm going to have a positive slope here, and this one's going to be slightly larger. So if I kind of fit that in, I'll have kind of a curve that looks something like that. Just a little bit of a curve. Again, it's not to scale. Now from 12 feet to 20 feet, the change in moment's equal to the area in the shear diagram. What's this area? That's 60 times 8. That's 480 positive. Oh, this is negative still. So that brings me to 100. Negative 100. And what's the slope? It's the shear, and the shear is constant and positive. So this section of the graph is a straight line. And it ends up at negative 100. Does it make sense that this is a negative 100 bending moment?
Yeah.
I think it does. So there's your moment diagram. So what's the maximum moment in the beam?
Negative 1588.
Negative 1588. It occurs at the load, at the fixed connection. What's the maximum shear? 108. Interesting enough, this beam has all negative moment. Wow. So if you made this out of reinforced concrete, where would your reinforcing go? Top or bottom? Top.
Top.
Any other questions?